Okay. The question is that what is the directivity of antenna? Yes, Vaibhav Patel. Anyone else can answer, give me answer? Komal Kolpe?
The
Yes.
ratio ratio of radiation intensity and radiation intensity of isotropic source.
Okay. Then what is the radiation intensity? Yes, Komal. What is the radiation intensity? And what is the isotopic radiation intensity? What is the exact difference between radiation intensity and isotopic radiation intensity? Yes.
Average radiated intensity is equal to the total power of radiation.
Okay. So now we are moved toward the next point, that is antenna efficiency. Before going to the antenna efficiency, we must be know that what is the efficiency. Anyone can say what is the efficiency? Yes. No one can. Okay. Can you see my presentation on screen?
Yes, sir.
Yes.
Yes, sir.
So after complete the directivity point, we had moved toward the antenna efficiency. When we are discussed directivity at that time, there was directivity is the ratio of antenna, that is what is radiation intensity and radiation intensity to the isotropic radiation intensity. Now after that, there is a point antenna efficiency. Now, what is the antenna efficiency? You know that antenna is the metallic rod which can be used to transmit or receive electromagnetic signal. Now, what is the efficiency? You have some potential, you have some efficiency. Is that clear? Now, antenna has also some efficiency. Antenna has some capacity to do work. Okay. Antenna has some capacity to cover the area by spreading or by transmitting or by receiving its signal. Now, antenna efficiency, it is efficiency, that is, it is associated with an antenna that are a number of efficiencies. That means a single antenna has different types of efficiencies. Then what are the different types? It can be discussed in this lecture also. Now, antenna has number of efficiencies and it can be see in that particular figure, in which specially there are three different efficiencies are present, in which one efficiency is radiation efficiency. That means how many amount of signal is radiated from antenna to the free space. That means, or which can be vice versa, antenna can be receive signal. That means antenna efficiency. Now both efficiencies are different. Transmitting efficiency is different and receiving efficiency is different, in which especially the total antenna efficiency can be derived or can be calculated by using E0. This is your total antenna efficiency. Now, total antenna efficiency is the combination of different efficiencies. That means there are number of efficiencies are present. For example, First one is radiation efficiency. That is, it is called as radiating efficiency, antenna radiation efficiency. Then reflection efficiency, conduction efficiency, and dielectric efficiency. That means in antenna rods, that means your antenna rod is a metal rod. In that particular metals, some of the energy is consumed. Some of the radiations are consumed. That means these are considered as conduction losses or dielectric losses. Now, what is the dielectric? You know that what is the dielectric constant? Dielectric means, Swaz, what is dielectric? Yes. What is the dielectric?
Electrical insulator.
Insulator.
Huh.
Okay. Now, your efficiency is also known as losses. That means when we calculate the efficiency at that time, we must be considered all type of losses. Okay, we must be considered all type of losses, and thus that losses may be from input terminal to the output terminal. That means it takes into account losses at the input terminal and within the structure of antenna. That means in total area or total antenna structure which are occupied by that particular metal rods, which may be considered as a efficiency. That means losses in the structure of the antenna from the input terminal is called as your efficiency. Now this structure has again different types, that is input terminal, output terminal, then dipole medium. So it includes also metallic rods, dielectric medium. So each and every losses are takes in account to the calculation of antenna efficiency. Now, this is in this diagram, this is your antenna which can be referred to calculation for the antenna efficiency, in which this is your input terminal, and your input terminal is known as gain reference point. Is that clear? Your input terminal of the antennas. Now here is the input terminal. Before input terminal, this is your transmission line. Now this is your antenna input terminal. Now this antenna input terminal is known as gain reference point. It can be considered as gain reference. And the end of that particular antenna, that is your output terminal, is known as directivity reference, because your directivity can be calculated after that. When directivity is calculated, at that time we had considered what is radiation intensity. Sorry, radiation efficiency or intensity.
Efficiency.
What should be considered for the calculation of the directivity? It should be radiation intensity or it should be radiation efficiency. What is that? Radiation intensity, not efficiency. Intensity.
Radiation
Okay, this is a complicated part. You should be keep it in your mind. That is U. U divided by U0 is your directivity. Now this antenna will be radiate some energy in a free space now. Now this is your beam width of that particular antenna. Okay, this is your 1 minute. Now, when directivity is calculated, at that time your directivity calculated by U divided by U0. U0 is total isotropic intensity. Okay. Now, total isotropic intensity means this antenna will be radiate energy in front of that particular antenna in that particular two yellow lines. Okay, or in, suppose this may be like that, or this may be your radiation intensity in front of antenna, but this antenna is radiating some energy in all directions. Now, this energy divided by this total energy, that is isotropic intensity, or sorry, radiation intensity divided by isotropic intensity. Now, this intensity is your radiation intensity, which is in front of your antenna. But now we are calculating antenna efficiency. When directivity is calculated, radiation intensity divided by isotropic radiation intensity is considered. But in directivity, we are considered every loss in the antenna. That means antenna radiates some energy, antenna reflects some energy, antenna conduct or it consumes some energy by that particular metal rods or dielectric losses. Now we can see that in this figure, that is, there is IC, there is ID, there is again IC and IC. Now these are the dielectric losses, that is current that is flowing through that particular dielectric medium, current flowing through that particular conduction medium, and overall efficiency which gathered at the antenna is known as your total antenna efficiency. Now, when we calculate the total antenna efficiency in diagram B, that is diagram B, this is your B, in which we have reflections because of the mismatch between transmission line and antenna. Now, again, this is your antenna and transmission line point where antenna and transmitter line are connected to each other. Now, when antenna and transmission line are connected to each other at that time, characteristic impedance or impedance matching of that particular antenna and transmission line is most important part. When transmission line is connected to the antenna, at that time output impedance, that is output impedance of that particular transmission line, should be matched with the input impedance of that particular antenna. Understand? Swaz?
Yes, sir.
Got this point? When we connect the transmission line to the antenna, at that time impedance of that particular transmission line should be matched with the impedance of that particular antenna. If there is some mismatch, if there is no proper matching of the impedance at the connection point of the transmission line antenna, at that time there is some reflections, and these reflections are due to the mismatch of the transmission line and antenna, and there is first loss. This is known as reflection losses. Got it? First loss, that is reflection loss. Reflection loss is due to the mismatch of the transmission line and the antenna. Is that clear?
Yes.
Yes, no doubt. Then After that, conduction losses and dielectric losses. Now your antenna is manufactured by using metallic rod, and two metallic rods are separated by using free space. Now free space has always some directivity. Is that clear? We are also calculated dielectric constant, that is epsilon 0. Is that clear? Which is equal to something 8.854 into 10 raised to something meter per second. आहे असं काहीतरी बघितलंय कुठं? Hello?
sir.
Yes. So this is your reflection, that is reflection loss due to the mismatch of the transmission line and antenna. Now second one is the conduction loss and dielectric loss now. And conduction loss and dielectric loss is commonly called as I square R loss. What is I square R losses? That is conduction and dielectric losses is called as the I square R losses. That is I square R is equal to काय असतं? माहिती का तुम्हाला I square R is equal to काय असतं? अनिकेत, what is the power formula? What is the power equation? कोमल कोळपे, you should be know that everything from the microwave,
Power is equal to V into I.
from the basic electronics. These are the some silly questions like that. It can be give answer by the first year or 11th standard students. What is the I square R? What is the I? Yes. I is current, R is resistance. Power should be product of current and voltage. Then what is the voltage? हे सगळं माहित पाहिजे रे बाळांना तुम्हाला, असं नाही चालणार. मी एमएससी सेकंडरीचं स्टुडंट आहे, तुम्हाला सगळं माहित पाहिजे. ओके. After that, these are the two different losses. One is the reflection loss, which is present at the antenna terminal, that is antenna initial terminal, in which it is present due to the mismatch between transmission line and antenna. And second one is the conduction and dielectric losses. Now it can be referred for the calculation of overall antenna efficiency. Now your overall antenna efficiency can be calculated or can be written by using E0 is equal to ER into EC into ED. Now total antenna efficiency is the product of reflection efficiency, conduction efficiency and dielectric efficiency of that antenna. Now E0 is your total efficiency which has or which have no dimension. It means it is dimensionless. Then another one antenna efficiency is reflection efficiency. It is also called as mismatch efficiency. It is also called as mismatch efficiency, and it can be calculated by using 1 minus sigma square. This is sigma square. Sigma
तो
काय
स्क्वेअर
आहे? हा?
तो आहे ना सर,
काय आहे ते?
टो
तो. Okay.
हा.
So 1 minus tau square. Is that clear? And also it is dimensionless. Now this is most important point. See carefully. That is, reflection efficiency can be calculated by using 1 minus tau square. Now what is the 2? It can be calculated at the time of standing wave ratio. स्टँडिंग वेव्ह रेशो जर माहित असेल तर हे माहित असेल तुम्हाला, लक्षात घ्या. लक्षात येते. जर स्टँडिंग वेव्ह रेशो नाही माहित तर नाही माहित हे होणार लक्षात. त्याच्यासाठी तुम्ही पहिलं रिव्हिजन केलं पाहिजे. स्टँडिंग वेव्ह रेशो काय आहे, हे काय आहे, टो काय आहे, सिग्मा काय आहे. ओके. नाउ थर्ड वन इज EC, that is conduction efficiency, it is also dimensionless. And last one is the dielectric efficiency, it is also dimensionless. Now, what is your two? It is voltage reflection coefficient. What is that? It is voltage reflection coefficient, and which is present at the input terminal of the antenna, which is present at the input terminal of the antenna, and it can be derived by using equation, or it can be derived by using input impedance of the antenna and characteristic impedance of the antenna, or characteristic impedance of the transmission line. Sorry, and not for the antenna, it should be calculated for the transmission line, because it is present along to the transmission line. You can see here, it is present in between the two transmission lines, that is coaxial transmission lines. After that, it can be it should be calculated by using input impedance minus characteristic impedance divided by input impedance plus characteristic impedance. Is that clear? Input impedance minus characteristic impedance divided by input impedance plus characteristic impedance. And by using this ratio, we can calculate your, what is this? Tau. And it is called as the voltage reflection coefficient. It is called as voltage reflection coefficient. That means when input impedance and characteristic impedance of the transmission line doesn't match with the impedance of that particular antenna, at that time there is some reflections are present. And now when the reflections are present, at that time that reflections may be calculated by using this ratio of the input impedance minus characteristic impedance divided by input impedance plus characteristic impedance, where your Zn is antenna input impedance and your Z0 is characteristic impedance of the transmission line. बघा, antennaच्या इनपुट इम्पेडन्स मधून ट्रान्समिशन लाईनचा कॅरेक्टरिस्टिक इम्पेडन्स काय करायचा आहे? मायनस करायचा आहे पहिल्यांदा. त्याला डिवाइड कशाने करायचं? टोटल इम्पेडन्सनी. टोटल इम्पेडन्स म्हणजे काय? व्हेन antenna and transmission line are connected together, at that time there is two different impedance are present. One impedance is for antenna, another impedance is for the transmission line. And in the transmission line there is a characteristic impedance of the transmission line is considered, and in the antenna there is input impedance is considered. And by using this impedance we can calculate the voltage reflection coefficient. Okay, and by using voltage reflection coefficient, that is when voltage reflection coefficient square may be subtract from the 1, at that time we can calculate the reflection efficiency, that is ER. That is ER is equal to 1 minus voltage reflection coefficient square. And this voltage reflection coefficient may be calculated by using antenna input impedance and characteristic impedance of the transmission line. We have considered two different impedances. One impedance from the antenna, another impedance from the transmission line. Is that clear? After that, we had calculated the voltage reflection coefficient. Is that clear? Voltage reflection coefficient. Now, by using voltage reflection coefficient, we can calculate the voltage standing wave ratio. Is that clear? Baga, we are going to step by step. At the initial condition, we had defined equation for the overall efficiency of the antenna. Now, overall efficiency of the antenna is the product of the reflection efficiency, conduction efficiency, and dielectric efficiency. Now, reflection efficiency is calculated by using the characteristic impedance of the transmission line and the input impedance of the antenna. Again, it is clear. After that, the ratio of that particular input impedance minus transmission impedance, that is characteristic impedance, divided by input impedance of antenna plus characteristic impedance of the transmission line. It is called as the voltage reflection coefficient. Now, when voltage reflection coefficient is calculated at that time, by using voltage reflection coefficient, we can calculate the voltage standing wave ratio. Now, voltage standing wave ratio may be calculated by using 1 plus voltage reflection coefficient divided by 1 minus voltage reflection coefficient. And this can be used to calculate the voltage standing wave ratio. Is there any doubt about voltage standing wave ratio or voltage reflection coefficient or total antenna efficiency? Is there any doubt? Yes?
No, sir.
You are free to ask questions. When you are asking question at that time, I'm considering your concentration is on your lecture, but when you doesn't ask some question at that time, I doesn't satisfy. So listen carefully. Your antenna efficiency, that means there are 3 different efficiencies are present. First one efficiency is reflection efficiency, then conduction efficiency and dielectric efficiency. Now, your conduction efficiency and dielectric efficiency calculation, that is separate calculation for the conduction and dielectric, is very difficult. But when we theoretically define the dielectric efficiency, conduction efficiency, it can be easy to understand what is the conduction and what is the dielectric efficiency. But when we go to the library and calculate or derive the antenna efficiency, that is the conduction efficiency and dielectric efficiency, by using a different experimental process, at that time it is so difficult to calculate separately, that is conduction efficiency and dielectric efficiency. So instead of calculation separately, that is we can use more convenient equation, that is we can combine these 2 efficiencies, that is conduction and dielectric efficiencies of antenna. And finally, when we go to the laboratory and we follow some experimental process, at that time we can combinedly calculate your conduction and dielectric efficiency, that is your AC, instead of calculation, that is instead of separate calculation. Now we can rewrite first equation, that is E0 is equal to ER into EC into ED. It can be rewrite by using ER into ECD. Now you know that what is the ER? ER is the 1 minus voltage reflection coefficient square. Okay. Now this antenna efficiency equation can be rewrite by using ECD into 1 minus and voltage reflection coefficient square. And this is your final equation of the antenna efficiency, where ECD is the combination of EC and ED, that is antenna conduction efficiency and dielectric efficiency. That means ECD is known as the antenna radiation efficiency now. बघा, मगाशी मी सुरुवातीला म्हटलं होतं की रेडिएशन इफिशियन्सी आहे, डायलेक्ट्रिक आहे, देन कंडक्शन आहे, देन रिफ्लेक्शन आहे. Now, instead of computing conduction efficiency and dielectric efficiency, we can simply call it as antenna radiation efficiency. Now only 2 efficiencies are remaining. That is antenna radiation efficiency and antenna reflection efficiency. Now, antenna efficiency is the product of antenna radiation efficiency and antenna reflection efficiency, which is used to calculate and which is related to the gain and directivity. Now, this is most important part when we go to the gain of the antenna. There are a number of different points are present at that time. These efficiencies are most important part. So if you have any doubt, then you can ask. Yes. Is there any doubt related to the antenna efficiency? Am I audible to everyone?
Yes, sir.
Then why you are not responding to me? You are the electronics student, you are the talented genius, and something words are used by our HODs, our faculties, and you cannot give me answers. So, this is who is the Anuja Chavan?
तर ती चुकून कोणतरी जॉईन झालेलं वाटतं.
बघा माझ्याकडे कोणी किती वेळ किती मिनिटासाठी जॉईन झालेला आहे याचा इन डिटेल रिपोर्ट ऑटोमॅटिक जनरेट होतो. तो आपले प्रिन्सिपल सर बघतात, त्याच्यासाठी लेक्चर अजिबात बुडवू नका. सगळेजणच बघतात, तुमचा लॉस होईल. ठीक आहे. तर तुम्हाला काय करायचं ते बघा. अनुजा चव्हाण, फक्त 9 जण. हाईट आहे, हाईट लेक्चर बुडवण्याची. सगळ्यांना एक मेसेज पोहोचवा, लेक्चर बुडवले तर अवघड होईल तुमच्यासाठी. नंतर कोणीही तुमची की उदय करणार नाही, लक्षात घ्या. लेक्चर इज मस्ट. तर काही क्वेश्चन आहेत का कोणाला?
सर ते इची आधी आहे ना आपण व्होल्टेज स्टँडिंग वेव्ह रेशोचं इक्वेशन काढलं, मग परत मग हे इक्वेशन E0चं कसं काढलं डायरेक्टली?
डायरेक्टली नाही काढलं आपण बाळा. सी केअरफुली. इज देअर प्रेझेंटेशन इज व्हेएबल? प्रेझेंटेशन दिसतंय?
हो.
येस येस.
हो सर.
बघा, दिस इज आवर फर्स्ट इक्वेशन. I will highlight this equation by using laser pointer. Now this is first equation, that is total antenna efficiency. Is that clear? Total antenna efficiency is the product of reflection efficiency and conduction efficiency and dielectric efficiency. Is that clear, Dikshit?
Yes sir, yes sir.
Okay, yes. Now reflection efficiency is present at the beginning of the antenna, where antenna and transmission line are connected to each other. At that time there is some voltage reflections are present, and at that point voltage reflection coefficient is calculated by using antenna impedance and characteristic impedance of the transmission line. Is that clear again?
Yes.
Yes. Now this is one part of the total efficiency, that is reflection efficiency. Now conduction efficiency and dielectric efficiency. I am saying that conduction efficiency and dielectric efficiency calculation in laboratory by using different experiments, it is very difficult. Understand again?
Yes sir.
That is conduction and dielectric efficiency calculation is very difficult. So it cannot be calculated separately, it cannot be measured separately. Is that clear? Theoretically it can be understand, it is dielectric laws, it is conduction laws, but practically by experimentally it cannot be determined separately, it cannot be measured separately. It can measure, but it is not so easy. So we use more convenient method. That means we are use a combined method, that is total radiation efficiency. Your conduction and your dielectric. Conduction means antenna rods. Is that clear?
Yes.
That means losses in that particular antenna rods and losses into the free space. That means in dielectric medium. Your free space is always dielectric medium. Is that clear?
Yes.
Now combination of that two losses, म्हणजे रॉड मध्ये किती एनर्जी वेस्ट झाली आणि फ्री स्पेस मध्ये किती गेली, ह्या दोन्हीचं मिळून काय कॅल्क्युलेट केलं आपण, अँटेना रेडिएशन एफिशियन्सी. दॅट मीन्स प्रोडक्ट ह्या दोघांचा, म्हणजेच काय त्याला टोटल म्हणले काय म्हटलंय, अँटेना radiation efficiency. And now total radiation efficiency or total radiation efficiency is the product of conduction efficiency and dielectric efficiency. Is that clear?
Yes, sir.
And total antenna efficiency is the product of, again, antenna radiation efficiency and antenna reflection efficiency. Is that clear?
Yes, sir.
ओके. आणि ह्यालाच गेन म्हणतात. गेन म्हणजे काय असतं, आउटपुट आणि इनपुटचं रेशो असतो, बरोबर आहे?
हो.
इज दॅट क्लिअर? आणि हे गेन सारखंच एक प्रकार आहे, गेनच आहे हा सुद्धा. किती रेडिएट एनर्जी केली आणि किती लॉस झाली आणि इनपुट किती होती टोटल, बरोबर आहे? याच्यावरून आता आपल्याला परत नेक्स्ट पॉइंट बघायचा आहे, कुठला, गेन. नाव व्हेन वी move toward the gain, at that time all of you must be know that what is the radiation intensity, what is the power which is accepted or reflected by the antenna. It should be know that everyone. Then what is the losses, what is the isotropic source, हे सगळं माहित पाहिजे तुम्हाला ज्यावेळेस तुम्ही गेन स्टडी करणार आहे. देर इज असं एक वन डेरिव्हेटिव्ह फॉर द गेन अँड विच कॅन बी discuss into the lecture. Tomorrow session.
सर आवाज येत नाहीये.
सरच लेफ्ट झाले काय? हॅलो,
ऐक की पशा,
सरच लेफ्ट झाले काय?
झाले
हा बोल.
काय करतोय?